Hi everybody, this is Algebra 2, Lesson 64, and this lesson covers complex fractions and complex numbers. Alright, to write the following fraction as a simple fraction. Okay, so this is going to take a couple of steps. We've got a plus 1 over b plus x. So first we're going to have to deal with this part of the fraction. Alright, so I'm going to rewrite this down here. So I've got 1 over b plus x. That's basically x over 1. So I need a common denominator, which would be b. So if I multiply this times b, I've already got a b, so I'm going to have 1 over b. And then I multiply this times b, and I'm going to have bx over b. Add those together, and I have 1 plus bx over b. Okay, so that's how I fixed this whole bottom, right, and made it be this new bottom. So now I'm going to rewrite that, a plus 1 over 1 plus bx over b. Now I got to get rid of this bottom, so I'm going to flip it and multiply. Okay, and then I'm going to do that same thing on the top, times b over 1 plus bx. Alright, these all cancel and got rid of my bottom of my fraction. On the top, I'm going to have 1 times that, so I'm going to have a plus b over 1 plus bx. Okay, now I need them to have a common denominator, which will be 1 plus bx, and this one will be 1 plus bx. Okay, now I'm going to multiply this times 1 plus bx. And the same thing on that one. We've already got it, so we won't worry about that because that's over 1. Alright, so then we'll have a times 1 plus bx plus b right there. Alright, so this one we could rainbow that out and we'd end up with a plus a bx. So when we add these, we're going to have a plus a bx plus b over 1 plus bx. And that's the answer to that one. So it just takes a couple of steps. First you got to get rid of this bottom part and then get common denominators. Let's try another one. Alright, so on this one I'm going to start by getting rid of this part. So I've got 1 plus b over x. I'm going to go ahead and write my 1 as 1 on top of a fraction. And I want x to be my new bottom, so I'm going to multiply this times x and that times x. These cancel. And I'm going to have x over x plus b over x, which would be x plus b over x. Okay, so that got rid of that part. So now I have a over x plus 4 over x plus b over x. Still, we got to get rid of this. So we're going to flip and multiply and do that on the top. Alright, all this cancels out. Now we have 4 times that. Now we got to remember that this 4 is really 4 over 1. So we're going to say that's going to be, we leave our a over x and we do 4 times x, which would be 4x. And then our bottom would be 1 times x plus b. Alright, so now we got to get a common denominator, which is going to be multiplying both of these together. So it's going to be x times x plus b. And another x. X times x plus b. And then we multiply both of these. Okay, right here we cancel out those x's, so it's a times x plus b, which would be ax plus ab. So I just rainbowed that there. And then 4x times, oh, we don't need the x plus b. X times 4x would be 4x squared. All right, so our answer is going to be ax plus ab plus 4x squared over x times x plus b. And I'm double checking to make sure that's right. Yes, it is. All right, so there's the answer to that one. All right, so these are kind of like ones that we've been doing before, just a little more complicated. Okay, if a number has a real part and an imaginary part, we call the number a complex number, and we've gone over this before. If the real part is written first and the imaginary part is written second, we say the complex number is written in standard form. So we always write the real part first and the imaginary part second, and that's a complex number. Now, every real number is a complex number because the real part could be 0 even if we only have an imaginary part, or if we only have a real part, the imaginary part could be 0. So every real number is a complex number whose imaginary part is 0, and every imaginary number is a complex number whose real part is 0. Okay, so in this one, it asks us to simplify. We remember that when both radicins are negative, the radicins can now be multiplied to change the form of the expression. First, we must use Euler's notation. So if I've got square root of -2 times the square root of -3, I can't multiply those yet, but I could say the square root of 2i times the square root of 3i. Then I've got the square root of 6i squared. I squared would be the square root of -1 times the square root of -1, which is going to be negative 1. So that will be -1 times the square root of 6. And that's going to be negative square root 6. Alright. It is important to break them down like this. Don't just try to look at it and figure it out. Alright, this one asks us to simplify this. So we've got 4i to the third. Alright, so first thing we're going to do on this one, the first step, is we're going to say 4 and we're going to pair our i's. So I to the third would be, we have 2 of them, and then we have another one. This part's going to be -1. 2i to the fourth. So we've got 2 i's right there and 2 i's right there. So that part's going to be -1 and that part's going to be -1. Alright, plus 2 times, okay, so that would be a square root of 9i plus square root of 3i times the square root of 3i. Okay, so right here we would have -1 times 4 would be -4. -1 times -1 would be positive, so that'd just be -2. These would just pretty much cancel each other out. Alright, square root of 9 is 3. 3 times 2 is 6i. Okay. Square root of 3 times square root of 3 is going to be 3. And I times I is -1. So that would be -3. Right, because that would be 9i times I. And that square root of 9. I times I is -1. Square root of 9 is 3. 3 times -1 would be -3. Alright, so now we can put together our real parts and our imaginary parts. So we've got -2, -4, -3, which would be, oh wait, this is -2. I forgot about that one right there because that was to the third. Alright, so that is not an imaginary part. I mean a real part. Alright, so we want our real numbers first. -2, -3 is going to be -5. And then our imaginary parts, -4, +6, that would be +2i. So there is our complex number written in standard form. Alright, we've got one more example problem. This one asks us to multiply. Alright, so we're going to, on this one, we're going to stack them first. So I'm going to write them stacked. Alright, so I've got 4 plus 2i. That's just this part, okay? And then I've got 3 minus 2i. And I'm going to multiply it. And how I do this is I'm going to go up first. I'm going to say 3 times 4 is 12. And then I'm going to go across to there. 3 times 2 is 6i. Alright. Okay, and then I'm going to go here. 2 times 4 would be 8i, and that would be negative 8i. And then 2 times 2 would be negative 4i squared, because I've got I times I on that one. Then I just add them up, 12. And then 6 minus, that would be negative 2i, and then negative 4. And we have 2 i's together, I squared, which would be negative 1. Negative times a positive makes positive 4. 12 will be 16 minus 2i. And that's the answer to that one. Basically, all I did was rainbowed. I said 3 times 4 is this 12 right here. And then 4 times 2 would be the negative 8i right there. And then 2 times 3 is 6i. That's that one. And then 2 times 2 is 4i squared. Alright, let's try another one. This one I'll just do it rainbowing. I won't bother with the stacking. Alright, 5 times 4 is 20i. 3 times 5 is 15. And that'd be I squared. That one's got I squared, so 2 i's. Alright, and 2 times 4 would be 8, and that would be negative 8. And then 2 times 3 would be 6i. Actually, I'm going to write this right here. 2 times 3 is negative 6i. Alright, both of these are going to be negative 1, so that would make that be negative 15. So now I've got 20i minus 6i, which would be 14i. Negative 15 and 8 would be negative 23. I got to put that first. And there's the answer to that one. Those are all pretty easy. Alright, go ahead and work the practice problems, and I'll come back and work them for you. Alright, so hopefully you pause the video and work these practice problems. Start with this one. Okay, so I'm going to start with this bottom part right here and try to simplify that. So I've got 1 over c plus 2m. I'm going to call that over 1. And that is a z. I hate when it's z. It always looks like a 2 to me. Alright, so that means I'm going to have to multiply. I'm going to have to find a common denominator. I want it to be z on both. So that's going to be, we're going to have to multiply that times z. So I've got 1 over z times 2mz. So I'd have 1 plus 2mz over z. Alright, so now I've got b plus 1 over 1 plus 2mz over z. Now I've got to flip this and multiply. Those cancel. I'll do the same thing here. Okay, so I multiply that times 1. So now I'm going to have b plus z over 1 plus 2mz. Alright, so then I need a common denominator, which will be 1 plus 2mz and 1 plus 2mz. And so I don't have to change that one. I have to multiply that times b, so b times 1 plus 2mz. So that would be b plus 2bmz. Alright, so I'm going to have b plus 2bmz plus z over 1 plus 2mz. And that is the answer right there. Alright, next one. Okay, so this has got a bunch of stuff for us to work here. I'm going to start with this part. So 5 plus 2s over z. My common denominator is going to be z, so I could just do 5z over z. So I just multiplied that side times z, and I'm going to get 5z plus 2s over z. Alright, so now I've got s over z plus 3 over 5z plus 2s over z. Now I need to flip this and multiply. Those all cancel out. This is really 3 over 1. And I have to multiply here, so I'm going to have 3z over 1 times 5z plus 2s. And that's s over z. Alright, now I need a common denominator here for these new bottoms, which is going to be, just multiply those two, so z, actually, let me go over here and do it. It would be z times 5z plus 2s. So z times 5z would be 5z squared plus z 2sz. Alright, so that's my new bottom, 5z squared plus 2sz. Did they do that in the answer? No. Okay, so we don't have to rainbow that. They left the answer just like this. Z times 5z plus 2s and z times 5z plus 2s. Okay, so up here we're going to multiply times z plus 2s, and same thing here. Okay, right here the z's cancel out, but we have to multiply it times this 5. So that'd be 5 times 5z plus 2s. And this one, that whole thing cancels out, so z times 3z would be 3z squared. Okay, so then we can, we can rainbow this term, so 5 times 5 is 25z plus 5 times 25 will be z squared. Oh, 5 times 2s, that would be 10s. There we go. So hard with all these s's and c's. Plus 3z squared over z times 5z plus 2s. Okay. Alright, I can put my z squared together. Let's see. Is that a Z or was that an S? Alright, so I could put, that's a Z. Let me look at the answer key on that one. The Z's and the S's are getting all mixed up here. Alright, so this is 2. That should be an S right there. So, let me fix that. Okay. So you gotta be real careful when you're writing. Your handwriting matters. That's a Z times 5S, right? Alright, so we should have Z times 5S plus, no, 5Z plus 2S. Okay, and then on the top we should have 2S squared plus 5SZ plus 3Z Z squared. And over here, this could equal, see, that's if we've already added them together. So this will be our 3Z squared, and we add those together, and we get 2S squared plus 5ZS plus 3Z squared over Z times 5Z plus 2S. If you got that far, good job. In the book, they have it factored as 2S plus 3Z times S plus Z over Z times 5Z plus 2S. Alright, I don't expect you guys to get that far. This is a good enough answer if you got that. Good job. Alright, a couple more. This one will be a little easier. That last one was a little challenging. Alright, I to the 4th, that means 1, 2, and another 1, 2, 5. Alright, so to the 3rd, we're going to have 1, 2, and 1, minus 3 times the square root of 3i times the square root of 5i. Alright, that would be negative 1. That would be negative 1. Negative 1 times negative 1 is positive 1. So that would just be 1 minus, that would be negative 1. So that would be positive 5i. Okay, right here, 3 times the square root of 3. Let's see, 3 times 3 would be 9. Negative 9i. And that would be square root of 5. Oh, we have to multiply that times that. So that would be, hang on. Alright, 3 times 5 is 15. 3 times 3 is 9. 9 times 5 is 45. Actually, we're going to have to leave that as square root of 15. 3 times 5 is square root of 15. So we're going to have 3 times the square root of 15 times I squared, which will be negative 1. Alright, so that will be Alright, so we've got 1 plus 5I times, that would be negative times a negative makes a positive, 3 times the square root of 15. Alright, so then we're going to put our real part first. 1 plus 3 times the square root of 15. That's our real part, plus 5I. So there's the answer right there. Alright, and one more. Alright, so this was one where we multiply. So I'm going to start here. 3 times 4 is 12. 3 times 5 is 15. That would be negative 15I. 5 times 4 is 20. That would be positive 20I. And then 5 times 5 is 25. That would be negative 25. 2 i's together there. Cross those out. That would be negative 1. That would just make positive 25. So we're going to move that positive 25 over here and put those together. That would be 37. And then we would have 20 minus 15 would be positive 5I. At least that one was easy. So 37 plus 5I. Alright, that is it for lesson 64. If you have any questions, just message me. Thanks for watching.